glass is a non-crystalline amorphous solid that is often transparent and has widespread practical, technological, and decorative usage in things like window panes, tableware, and optoelectronics. Scientifically, the term glass is often defined in a broader sense, encompassing every solid that possesses a non-crystalline structure at the atomic scale and that exhibits a glass transition when heated towards the liquid state. The most familiar, and historically the oldest, types of glass are based on the chemical compound silica, the primary constituent of sand. The term glass, in popular usage, is often used to refer only to this type of material, which is familiar from use as window glass and in glass bottles. Of the many silica-based glasses that exist, ordinary glazing and container glass is formed from a specific type called soda-lime glass, composed of approximately 75% silicon dioxide, sodium oxide from sodium carbonate, calcium oxide, also called lime, and several minor additives. A very clear and durable quartz glass can be made from pure silica, which is very tough and resistant to thermal shock, being able to survive immersion in water while red hot. However, quartz must be heated to well over 3000 degrees Fahrenheit before it begins to melt, and it has a very narrow glass transition, making glass blowing and hot working difficult. In glasses like soda lime, the other compounds are used to lower the melting temperature and improve the temperature workability of the product at a cost in the toughness, thermal stability, and optical transmittance. Many applications of silicate glasses derive from their optical transparency, which gives rise to one of silicate glass's primary uses as window panes. Glass will transmit, reflect and refract light. These qualities can be enhanced by cutting and polishing to make optical lenses, prisms, fine glassware, and optical fibers for high-speed data transmission by light. Glass can be colored by adding metallic salts, and can also be painted. These qualities have led to the extensive use of glass in the manufacture of art objects and in particular, stained glass windows. Although brittle, silicate glass is extremely durable, and many examples of glass fragments exist from early glass-making cultures. Because glass can be formed or molded into any shape, and also because it is a sterile product, it has been traditionally used for vessels, bowls, vases, bottles, jars and drinking glasses. In its most solid forms it has also been used for paperweights, marbles, and beads. When extruded as glass fiber and matted as glass wool in a way to trap air, it becomes a thermal insulating material. And when these glass fibers are embedded into an organic polymer plastic, they are a key structural reinforcement part of the composite material fiberglass. Some objects are so commonly made of glass that they are simply called by the name of the material, such as drinking glasses and reading glasses. In science, porcelains and many polymer thermoplastics familiar from everyday use are glasses too. These sorts of glasses can be made of quite different kinds of materials than silica, metallic alloys, ionic melts, aqueous solutions, molecular liquids, and polymers. For many applications, like glass bottles or eyewear, polymer glasses are a lighter alternative than traditional glass. Silicate glass. Ingredients: silica is a common fundamental constituent of glass. In nature, vitrification of quartz occurs when lightning strikes sand, forming hollow, branching root-like structures called fulgurite. Fused quartz is a glass made from chemically pure silica. However, its high melting temperature and viscosity make it difficult to work with. Normally, other substances are added to simplify processing. One is sodium carbonate, which lowers the glass transition temperature. The soda makes the glass water-soluble, which is usually undesirable, so lime. Some magnesium oxide and aluminium oxide are added to provide for a better chemical durability. The resulting glass contains about 70 to 74% silica by weight and is called a soda-lime glass. Soda-lime glasses account for about 90% of manufactured glass. Most common glass contains other ingredients to change its properties. Lead glass or flint glass is more brilliant, because the increased refractive index causes noticeably more specular reflection and increased optical dispersion. Adding barium also increases the refractive index. Thorium oxide gives glass a high refractive index and low dispersion and was formerly used in producing high-quality lenses, but due to its radioactivity has been replaced by lanthanum oxide in modern eyeglasses. Iron can be incorporated into glass to absorb infrared energy, for example in heat-absorbing filters for movie projectors, while cerium oxide can be used for glass that absorbs UV wavelengths. The following is a list of the more common types of silicate glasses, and their ingredients, properties, and applications. Fused quartz, also called fused silica glass, vitreous silica glass, is silica in vitreous or glass form. It has very low thermal expansion, is very hard, and resists high temperatures. It is also the most resistant against weathering. Fused quartz is used for high-temperature applications such as furnace tubes, lighting tubes, melting crucibles, etc. Soda-lime silica glass, window glass. Silica 72% plus sodium oxide 14.2% plus lime 10.0% plus magnesia 2.5% plus alumina 0.6%. Is transparent, easily formed and most suitable for window glass. It has a high thermal expansion and poor resistance to heat. It is used for windows, some low-temperature incandescent light bulbs, and tableware. Container glass is a soda-lime glass that is a slight variation on flat glass, which uses more alumina and calcium, and less sodium and magnesium, which are more water-soluble. This makes it less susceptible to water erosion. Sodium borosilicate glass, Pyrex. Silica 81% plus boric oxide 12% plus soda 4.5% plus alumina 2.0%. Stands heat expansion much better than window glass. Used for chemical glassware, cooking glass, car headlamps, etc. Borosilicate glasses have as main constituents silica and boron oxide. They have fairly low coefficients of thermal expansion, making them more dimensionally stable. The lower coefficient of thermal expansion also makes them less subject to stress caused by thermal expansion, thus less vulnerable to cracking from thermal shock. They are commonly used for reagent bottles, optical components and household cookware. Lead oxide glass, crystal glass. Silica 59% plus lead oxide 25% plus potassium oxide 12% plus soda 2.0% plus zinc oxide 1.5% plus alumina 0.4%. Because of its high density it has a high refractive index, making the look of glassware more brilliant. It also has a high elasticity, making glassware ring. It is also more workable in the factory, but cannot stand heating very well. Alumina silicate glass. Silica 57% plus alumina 16% plus lime 10% plus magnesia 7.0% plus barium oxide 6.0% plus boric oxide 4.0%. Extensively used for fiberglass, used for making glass-reinforced plastics and for halogen bulb glass. Oxide glass. Alumina 90% plus germanium oxide 10%. Extremely clear glass, used for fiber optic waveguides in communication networks. Light loses only 5% of its intensity through 1 kilometer of glass fiber. Most optical fiber is based on silica, as are all the glasses above. Another common glass ingredient is crushed alkali glass or cullet, ready for recycled glass. The recycled glass saves on raw materials and energy. Impurities in the cullet can lead to product and equipment failure. Fining agents such as sodium sulfate, sodium chloride, or antimony oxide may be added to reduce the number of air bubbles in the glass mixture. Glass batch calculation is the method by which the correct raw material mixture is determined to achieve the desired glass composition. Moldavite, a natural glass formed by meteorite impact, from Bosenese, Bohemia. Tube fulgurites. Quartz sand is the main raw material in commercial glass production. Trinitite, a glass made by the Trinity nuclear weapon test. Physical properties. Optical properties. Glass is in widespread use largely due to the production of glass compositions that are transparent to visible light. In contrast, polycrystalline materials do not generally transmit visible light. The individual crystallites may be transparent, but their facets reflect or scatter light, resulting in diffuse reflection. Glass does not contain the internal subdivisions associated with grain boundaries in polycrystals and hence does not scatter light in the same manner as a polycrystalline material. The surface of a glass is often smooth since during glass formation the molecules of the supercooled liquid are not forced to dispose in rigid crystal geometries and can follow surface tension, which imposes a microscopically smooth surface. These properties, which give glass its clearness, can be retained even if glass is partially light-absorbing, i.e., colored. Glass has the ability to refract, reflect, and transmit light following geometrical optics, without scattering it. It is used in the manufacture of lenses and windows. Common glass has a refraction index around 1.5. This may be modified by adding low-density materials such as boron, which lowers the index of refraction, or increased with high-density materials such as lead oxide, or in modern uses, less toxic oxides of zirconium, titanium, or barium. These high-index glasses causes more chromatic dispersion of light, and are prized for their diamond-like optical properties. According to Fresnel equations, the reflectivity of a sheet of glass is about 4% per surface, and the transmissivity of one element is about 90%. Glass with high germanium oxide content also finds application in optoelectronics, e.g., for light-transmitting optical fibers. A wine glass. Simple optical device. The magnifying glass. Glass petri dish. Other properties in the process of manufacture. Silicate glass can be poured, formed, extruded and molded into forms ranging from flat sheets to highly intricate shapes. The finished product is brittle and will fracture, unless laminated or specially treated, but is extremely durable under most conditions. It erodes very slowly and can withstand the action of water. It is resilient to chemical attack and is an ideal material for the manufacture of containers for foodstuffs and most chemicals. Contemporary production. Following the glass batch preparation and mixing, the raw materials are transported to the furnace. Soda-lime glass for mass production is melted in gas-fired units. Smaller-scale furnaces for specialty glasses include electric melters, pot furnaces, and day tanks. After melting, homogenization and refining, the glass is formed. Flat glass for windows and similar applications is formed by the float glass process. Developed between 1953 and 1957 by Sir Alistair Pilkington and Kenneth Bickerstaff of the UK's Pilkington Brothers, who created a continuous ribbon of glass using a molten tin bath on which the molten glass flows unhindered under the influence of gravity. The top surface of the glass is subjected to nitrogen under pressure to obtain a polished finish. Container glass for common bottles and jars is formed by blowing and pressing methods. This glass is often slightly modified chemically for greater water resistance. Further glass forming techniques are summarized in the table glass forming techniques. Once the desired form is obtained, glass is usually annealed for the removal of stresses. Surface treatments, coatings or lamination may follow to improve the chemical durability, strength, or optical properties. Impurities give the glass its color. Some of the many color possibilities of glass. Transparent and opaque examples. Glass can be blown into an infinite number of shapes. Coloring glass may be obtained by addition of electrically charged ions that are homogeneously distributed, and by precipitation of finely dispersed particles. Ordinary soda-lime glass appears colorless to the naked eye when it is thin, although iron oxide impurities of up to 0.1 Wt% produce a green tint, which can be viewed in thick pieces or with the aid of scientific instruments. Further FeO and Cr2O3 additions may be used for the production of green bottles. Sulfur, together with carbon and iron salts, is used to form iron polysulfides and produce amber glass ranging from yellowish to almost black. A glass melt can also acquire an amber color from a reducing combustion atmosphere. Manganese dioxide can be added in small amounts to remove the green tint given by iron oxide. When used in art glass or studio glass is colored using closely guarded recipes that involve specific combinations of metal oxides, melting temperatures and cook times. Most colored glass used in the art market is manufactured in volume by vendors who serve this market, although there are some glass makers with the ability to make their own color from raw materials.